Hello. I'm often asked, when should I install my ultrasonic or radar level sensor in a standpipe? Well, the short answer is, in liquid applications with extreme agitation or limited measurement space, and, in the case of ultrasonic only, those with surface foam. So let's look at the basics, and then go over standpipe best practices. A standpipe is a simple barrier that isolates the sensor's acoustic or RF measurement signal from the rest of the tank application. This benefits the sensor under the following three circumstances. First, extreme agitation can scatter the measurement signal, cause the output to bounce, and cause erratic performance. Installing the sensor in a standpipe dampens the agitation at the point of measurement. Second, tanks like plating baths have little free space, and their internal structures can disrupt the measurement signal. Installing the sensor in a standpipe reduces the measurement footprint and separates it from obstacles. Third, surface foam can absorb an ultrasonic measurement signal and cause erratic performance. Installing the sensor in a standpipe separates the foam from liquid at the point of measurement. With the basics understood, let's go over standpipe best practices, including selecting the right pipe size, fitting components, and location for placement in your tank. This will ensure the success of your installed ultrasonic or radar level sensor. First, let's talk about pipe selection. Choose a standpipe diameter that's 2 inches or more, or at least 1.3 times the sensor's mounting thread size. For example, if the sensor's mounting thread is 1.5 inches, then a pipe diameter of 2 inches or greater will work. With the pipe diameter determined, select a single pipe that's slightly longer than the tank height. Do not use 2 or more pipes coupled together, as their connection may disrupt the measurement signal. Select a thread-to-slip coupling that matches the pipe diameter. You'll also need a reducer bushing. Only one reducer is allowed. To equalize pressure within the pipe, drill 2 1/4-inch holes on opposite sides of the pipe, just below the coupling. Do not drill additional holes along the pipe's continuum, as they may disrupt the measurement signal. Next, you'll need to determine and cut the bottom of the standpipe to the appropriate length. This is typically the distance from the sensor's installed location to the bottom of the empty tank. Do not cut the standpipe shorter than the sensor's measurement span, as this may disrupt the measurement signal. Then, cut a 45-degree angle on the bottom of the pipe, and rotate the 45-degree opening away from sources of agitation, such as a pump inlet or mixer blade. Finally, make sure to place your tank's low-level control set point above the 45-degree cut. This helps to prevent surface foam or floating debris from being ingested into the pipe. In summary, a standpipe is an effective installation technique for applications with extreme agitation, limited measurement space, and surface foam. Follow the best practices we've shared to install your sensor, and you'll do just fine. Flowline is reliable level measurement.